Okay, so this question is about boiling point, and boiling point is really a physical property. And so remember that physical properties depend on intermolecular forces. All right, and the bottom line is more intermolecular forces means more energy to separate a molecule from another molecule. And if that means takes more energy to just separate the molecules, then ultimately that means a higher boiling point. So we have to examine the intermolecular forces that these two molecules have. This one is polar, but so is this one. It's polar as well. So they also have dispersion forces. Okay, so what's the difference? Then the difference is in the dispersion forces. That's what leads to the difference in boiling points because of the difference in the intermolecular forces. This guy is a little bit more spread out. This one is a little bit more compacted, a little bit more symmetrical. They both have similar symmetry, but there's just slightly more compactability in the one on the left. So there's more degrees of freedom. In the one on the right, it's a little floppier. Since it's a little floppier, it's more polarizable. And that an increase in polarizability, that's what means higher boiling point. So again, for the ones above, the longer the chain, if we're talking about the same atoms, the more polarizable it is, and the more polarizable it is, the higher the boiling point. Okay, for the one below, it is a different number of atoms. They're not polar, they both have dispersion forces. And so at the end of the day, the one with more atoms, that means more polarizable. And so that means the one with more atoms has the higher boiling point. Okay, there you go.